Well, hello, everyone. Welcome to Wednesday. How's everybody doing? Boy, I feel like it's that time of the semester when I'm just like, I'll get to the end eventually. It's like everything's just like happening all at once, you know? Busy, busy. It looks like we're going to have a pretty good weekend weather-wise. That's exciting. And we're going to do more coding in here today. So today we're going to kind of jump into what I would consider to be some of like the very fundamental concepts in coding. We're going to do that with p5.js as per usual. And today we're going to be starting to get into some things that will help us really take our sketches and make much more complex objects, both in terms of what's up on the screen and also how we interact with them via the keyboard, mouse, and all those other things. So before I get started, does anybody have any questions about code and stuff? I should teach a class called Code and Stuff. All right, great. So yeah, today we're going to be talking about 3 things if we get that far. We might not get to the last thing, but that's okay because the entire class period next class is devoted to that 3rd thing. Today we're going to talk about, we'll talk about how does basic math work. We'll talk a little bit about variables, which we touched on last class. And then the major thing for today is we're going to talk about conditional statements. Conditional statements are statements like, if you're a jerk, I'm not hanging out with you. That is a great example of a conditional statement. And we can use those in programming for sort of similar types of logic. So we are going to get started reviewing a little bit from last class about variables, and we'll kind of add on to that. So I'm just going to double check that I'm recording. So this is the code that we worked on last class, you may recall. I'm going to clean it up and kind of adjust it for working today. So I don't think we need the line drawn here, or print blah, or blah. And so that basically gets us to a point where we have just the ellipses drawing, and they're quite large right now, so kind of just knowing a little bit about what I want to do later, I'm going to reduce the scale of these. And I could definitely just reduce this number and say, okay, that's 300. If I want it to be half that size, it's 150, right? That is totally legitimate. There's nothing technically wrong with that. But one thing that I want y'all to start thinking about is parameterization. So if we take this 300 and we just divide it by 2, later on, that might actually make sense based on what we're going to do with a variable. So this is something that I'm going to use later. It's just a different way of constructing this number, right? Like they both equal the exact same thing. It's a different way of writing it. And so what I think we're going to do, first I'm going to just test this. And if you want to, you can use the auto refresh button, and that will kind of automatically test what you're writing in the code thing here. But in this case, you have to play it once after you click auto refresh. So there we are. Our circles are half as large. So that's pretty, what we would expect, right? But let's talk a little bit about variables. So we made a variable called blah up here. We said let blah equal 0. And right now, I think I'm actually going to change blah. I'm going to change the name of this variable to s. And I'm going to make s equal 2. And then here, I'll say this corresponds to scale. And so what I'm going to do is I'm going to come in here, and I'm going to assign s instead of 2. And so again, this is just a sort of substitution. It's doing exactly the same thing, or it should be eventually. I think I deleted a end parentheses here. That was unfortunate. And then go ahead and play it again, and we have exactly the same thing happening, right? So you may be asking yourself, well, Meg, why would you even do that? That seems like extra work in some ways, and like it's not changing anything. Oh, but wait. You can, now that you have something called S, you can change the value of S up here and make it like, say, 10. And it's a much more convenient way to change like multiple things at once, right? Because we have now 6 different scale parameters associated to S. So we can change it at the top in one place. So what that's called, there's a fancy word for that, that's called parameterization, which basically means that instead of sort of hard typing numbers, you're sort of typing variables that you may reuse, and then those variables can be adjusted, you know, only once instead of potentially like hundreds of times, right? So it's one of the very most fundamental things about coding. If we wanted to talk about variables a tiny bit, and this is certainly in the slides, p5.js has a kind of somewhat unique way of handling variables and their data, and that is that it is called a not strong-typed language. So what do I mean by strong-typed? Well, there are different data types that are in, that you can use in code. And so right now, we're using one of the simplest forms of data, which is an integer number, right? It's a very, like a whole number. You can also use numbers with decimal points. You can use words. You can use image objects, maybe from other, like from website URLs. There are so many different things that you can cram into a variable. Now, the important thing to know, some programming languages, some sort of more, some would consider probably more full-featured C-derived programming languages, actually ask you in this declaration, they ask you, instead of using var, you would actually declare the type of variable. And so you would say int x instead of var x. Now, what that means, that's called strong typing, and that basically means that you're telling the compiler or the script interpreter what type of variable that you're using. And if you try to use data that's not the same data type as the variable that you've described, it will honk back at you and be like, data type mismatch. Super annoying. So in some ways, some people think that it's easier to use a language that doesn't have strong typing, like P5, where you can have multiple different types of data, and all you have to do is say var, and then declare it. So let's kind of put this into practice here. So if I have, let's see, s equals 10, maybe down here in the draw function, I'll try to assign to s a word. I'll just call it word. So there's nothing technically wrong with this syntax. Except, there's nothing technically wrong with it, except that it seems to have completely broken my sketch. So why did it completely break my sketch? Well, because up here, by assigning s a number, that is a shorthand way of telling the compiler or the script interpreter that you are using a number and that this is now a number type of variable. So the bottom line is you don't even really have to know which data type you have, although it's a really good idea. The big thing is that you can't mix and match data types. So if we were to create here to say something like s equals word, up here, that would probably, at the very least, allow our sketch to run. Let me try single quotes here. And I'll just comment this out real quickly. So yeah, basically, the bottom line is don't mix and match variable data types. So if you have any questions about that, that's like an excellent thing to email me about. And by the way, if you have an error that gets generated and it says something like data type mismatch, that's what this problem is, or what it would be. So basically here we can take S and we can assign any number to S. We can assign 100, should run just fine. You can see now that our things are very small. We can also assign 100.001, should work. Yep, works fine. So there's some flexibility. I would definitely steer clear of like taking something that's used to store numbers and sticking words or letters in it. That is definitely not going to work. So let's kind of move on a little bit. In terms of asking for help, obviously you can reach out to me over email and ask for help. Let me show you sort of the process that you would go through if you want to request my help. Probably the best thing to do is to get your sketch, whatever you're attempting to do, and go ahead and make sure that you're signed in to the P5 editor. If you're not signed in, you won't be able to save. Really common, this actually happened to me yesterday after class. I made this sketch and I was like, oh crap, I'm not signed in. What do I do? Just cut and paste, copy all of your code, open up a new new tab, sign in, paste your code in, and then from there you can save it. And so when you hit the save button, it will generate a longer URL. If you don't have the save button, if you haven't saved it once, it will just show here editor.p5.js.org. So if you wanted to share this code with me, you would basically just take this URL, copy the URL, and then you would send it to me in an email. I will not be able to actually work on your code, but I will be able to see it and suggest changes that I will just email back to you. So that is the best way to kind of like ask me or the TAs for help remotely. And then if I can't resolve the issue with more than like 2 or 3 emails, that's usually the point at which I would request a Zoom call. Because basically it's just like, we need a little more interaction. So yeah, that's how to deal with that. And let's check back in with the data type thing. Yes, so, and let's talk a tiny bit about basic math. We already have done some basic math in our sketch. So we've used the division operator, which is the slash right here. We can also, probably the easiest way to kind of explore this is to print the value of S to the console. And then up here, try doing some stuff to S. So S, you can make S decrement, which this is actually completely equivalent to S plus equals 1, which is completely equivalent to S equals S plus 1. So these are sort of varying degrees of shortcuts. So saying S equals S plus 1 is definitely doing exactly what? It's adding 1 to the value of X, of S in this case. And also in this case, S plus equals 1 is that plus equals is a shortcut operator, which is called the addition assignment operator. There's an assignment operator for every math function. So there's a times assignment operator if you wanted to just make S equals to S times 1. And these are all outlined. I'm not going to go through every single one because they're very repetitive. But these are outlined in this page on the slides for your reference. So in this case, we're using S++, which is the increment operator. And you can see that in the console, the value of S is just continuing to go up and down. It's so far up right now, in fact, that that's the number we're dividing the scale by. So you can barely see these. They're super tiny right now, right? Because they're just like infinitesimally small. We could certainly take this same number and decrement it, which would be using the minus symbol. And it will just give us a very different look, right? So now we're going kind of into the negative, right? We also have a couple of unique operators, the ones that you've heard of before, like, you know, multiplication, division. They work just like the same way that we do basic arithmetic, right? And so I really hope that you're familiar with them. I'm 100% sure you are. We're all like reasonably educated people here. So if you're not a computer science person, this is definitely an operator that you have never seen. And believe it or not, when you're doing animation, it's a really useful operator. So it's called the modulo operator, and it's also sometimes called the remainder operator. So the modulo operator is one that when I was first, in computer science, I was sort of like, wait, what? I remember it being kind of like difficult to get used to, but once you finally get used to it, it's super useful. So I'm going to go ahead and show you how it works in like a really concrete way. So we have this thing called frame rate, which we're using right now. And then there's also a system variable, which means that it's a variable that's sort of stored in the P5 language, similar to mouse X here or RGB. And it's called frame count. So I think I'm going to comment this little bit out here, quit decrementing, and call this something like, it'll print the frame count. Nope, not that. Sorry, oh God, this is so annoying. So my advice to you, if this happens, is not to, damn it. I'm going to have to restart this tab. So I actually just committed one of the sort of like cardinal problems here. When you use print without an argument in it, and you run the sketch, it will open up the print window to actually see, okay, this is how I print. But when you, basically because I had auto refresh on, it mistook my typing as intent. And then I'm sort of stuck in this loop. So the best thing to do, I think, recently saved my sketch, so I'm just going to try reloading the page and see what it comes up with. Okay, that's fine. So then I can definitely comment this out. I'm going to turn off auto refresh while I'm working on this. Print function specifically, because right now it would be popping up that window, which is just so, it's one of those annoying things. So in this case, I'm going to go ahead and, let's see, print the frame count. And we can see that frame count kind of coming down here. And indeed, we are generating frames. Okay? So now you might be asking yourself, well, okay, that's great. What's the point here? Well, I would say, how about here, let's print frame count modulo 10. And we're going to come back to this in just a second. So you can see that right now, instead of iterating through the values that frame count is kicking out, it's actually asking what is the remainder of the current value divided by 10. And this can be super useful. We're going to come back to this in a few minutes when we do if statements, because you could construct something like, what if every 10 frames I want to turn the background a certain color? That is a completely reasonable request. It's a request that seems pretty time-based, right? Like you want to do something on a certain interval. And it just so happens that by using the modulo operator here that we're generating an interval of 1 through 10 every once in a while. So what we can ask at some point is, if frame count modulo 10 equals 0, then do this thing. And if it doesn't, then don't do this thing. And so that's kind of how I think I'm going to introduce if statements to you. So let's kind of move in there. So if statements are probably like one of the most important, I talked about that yesterday, we already talked about this. Yeah, if statements are definitely, I would say, one of the most very fundamental aspects of coding. And I think that if statements are specifically sort of geared towards applying if-then type of logic to the way that you construct your sketches. So for example, if I wanted to say something like, I'm gonna leave this stuff for later. How about I go back to this thing where I'm using S minus minus. And I'm gonna go ahead and run that, and it's getting pretty deeply in there. How about if I say something like, if S is less than 0, then, and there's no then, obviously in like sort of plain language, it's these curly brackets, or basically the whatever happens then. Then let's draw the ellipse. Let's turn the fill of the ellipse to something like red, which happens to be 255, 0, 0, I think. So it's pretty straightforward. So we're going to start off, and it's pretty much immediately heading into that. So I think it's just happening faster than we can say. So how about we start with like this at 100, just so we have a little bit of lead time before it decrements all the way down to 0. Okay? So we're black and white, then we go red when it hits 0. Okay? Super fun, super easy. So that seems fantastic. I think I'm going to keep this decrementing happening, but let's say we want to only do this decrement to a certain level, right? Let's say maybe we only want to take it down to negative 100. So we can certainly do that with an if statement. So here we would construct our if statement to say if S is greater than or equal to negative 100, then we're going to subtract from it. And you do need these closing curly braces. So let's try that out and see what happens. So one thing that I really am kind of wanting to do right now is I'm really wanting to print the value of S, just because I'm curious where it's starting and where it's winding up. So I think here I'm going to print the value of S. Okay, so I am making probably one of my most common coding mistakes. Can anyone kind of like chime in on what's wrong here? Yeah. I totally did. I put less than instead of greater than because my brain not work. It's one of those things. So that's one of the reasons why I'm a huge fan of printing things to the console, because you could bang your head against this literally for an hour and be like, why does my code not work? Oh my God, why is it not working? And if you can just, literally have some insight into like why it's not working, which when it's printing out here, it says, hey, I'm at 100, so it's obviously not like, it's great. It's obviously greater than a negative 100. So that gives me like a clue as to what my issue is. And this is a mistake that I make like literally all the time. So now it's working pretty much exactly as I would expect. And you can see it's kind of hovering at negative 101. So by putting the decrement inside of this if statement, we're basically able to cap that action, right? And kind of make it so that it's limited into a certain range. Let's go ahead and sort of use this frame count as kind of our last engagement with the if statements. So another thing that you can do with if statements is you can do a calculation. So here we're doing sort of evaluation, assignment operators. But here, if I wanted to say if frame count modulo 10 is equal to 0, which, by the way, that is shorthand for every 10 frames, or longhand for every 10 frames. Also, I want you to take a special note of the fact that when you're using the equal sign inside of an if statement, it's a little bit different than you would use it in like assigning the value of a variable. I need a semicolon there. So definitely, how is it different? Well, the main difference is that you use the double equal sign, which is called the equality evaluation operator. What a wonderful name, yeah. But yeah, that's basically what it is. And if you used a regular equal sign here, it would probably honk an error message at you. So we're asking it to sort of evaluate this modulo every 10 frames. And what we're hoping to do here, I think, is to, how about every 10 frames, let's make the fill green or blue. The reason I'm using fill here is not necessarily because that's like the most awesome thing to do. It's because it's highly visible and I'm trying to show you stuff. So it's just like the most obvious sort of visual way to kind of see what's happening. Okay, so yeah, let's give this a shot and see what happens here. Unexpected end of input. Okay, so here's another classic error. So I can say 100% what the error is. It's that we have these 3 if statements that have their little curly braces. They should have an opening and closing curly brace. This one has one. And this one sort of has one, but hey, guess what? This closing curly brace is actually the closing curly brace for the draw function. So that's why it's kind of honking at me right now. So what I need to do is I need to give the if statement its own closing curly brace, and then it should be happy. All right, so now you can see every 10 frames, it's going to shift color. It's kind of annoying that it's like not very, okay, so there's a couple of things happening here. There's like a precedence thing happening. So basically what's happening is this S being less than 0 is turning the fill. And so as you can see, once S goes less than 0, that statement is always true, right? So once we iterate down to where it's like 101, this is 100% true. So we actually might make a slightly more complicated if statement, but for now, let me just comment this out. And I am going to put down here an else situation, just to show you how that works. So I'm going to say if this doesn't turn it green every 10 frames, I want something else to happen. And so that's why you get this second part to the for loop. And you can also actually probably, it might be better to call this else if. So, sorry, else, actually. If you want this to have a condition, you would use else if, and then you can put a condition inside parentheses. So let's go ahead and see how that works. And so this is doing pretty much exactly what we hope. So it's going kind of small. So I think here I'm going to actually change this to capping out at 0. Although maybe 10 would be better, because then it would still be nice and visible. So you can see how it's turning that ball, every 10 frames. It's pretty obvious, right? And then all the other all the other balls that are drawn on the other frames are, drawing as red. So this is I would say like a pretty reasonably complicated kind of function. If we wanted to, I'm going to comment this out just for now so I can kind of work in some other areas. So let's kind of think about this maybe in a different way, and I'm going to tell you some other things about if statements. So both of the if statements that we have right now are asking for a single condition. So this, well, all three of the if statements that we have. This one's asking for whether something is less than or greater than or equal to something. This one's asking if something is less than something. And this one is asking what is the value of this, expression, right? So what do we do from there? Well, you can certainly take these expressions and combine them within a for loop, within a if statement. And so let's kind of take a look and see what that might look like. So here I have, okay, if s is less than 0, I can use something called logical and it's every 10 frames, then I can do some stuff. Okay? So what this is going to do is, it's actually, let me just, so I retain sort of the original version for y'all, I'm going to leave some of the stuff commented in the code in case you decide to use it. So let me just real quickly cut and paste this so we can have a separate thing. Okay, so here I would say let's go ahead and now say we're going to use and the frame count is every 10 frames. This is one of my favorite operators. It's called the logical and operator. So logical and means that this has to be true, this has to evaluate as true, and this has to evaluate as true. So if you ever meet a friend and you're talking politics with them and they're engaging in some seriously binary thinking, you could totally tell them that it's both and you can use that logical and to kind of arm your philosophical argument. So yeah, indeed, both things will have to be true in order for us to do stuff. So I'm going to go ahead and uncomment this. And let's just see what happens here. Okay, so does anyone want to tell me what the issue is? It's, I'll give you a hint. It's one of these statements is not true. And why is it not true? It's because I told it not to be. That's usually the problem. You have a pretty good idea, I think. Yeah.
As far as I can tell, s is never going to be less than 0.
Right. So I'm basically asking it to say if s is less than 0, and actually here I'm decrementing it only if it's if s is greater than or equal to 10, then I'm putting it down. Although, yes, right, quite right. So basically what I think we can do here is do something like if s is, let's say, equal to 9, because I'm pretty sure it's hitting 9. Okay, there we go. So let's see, and frame count is equal to 10. Now, this is probably not exactly what we had intended because it's kind of turning on and then never turning off. So in order to get this to sort of look, I think, the way we probably would expect it to, we would want to turn it back to white. So we would just use else here and then stick in a white fill. And if we're using something on the grayscale, we only need one number. So now we're getting that sort of predictable behavior of like every 10 frames it's flipping one of these red, right? So let's try something else, which is another operator. So here we're basically saying, okay, if both of these conditions are true, then turn it red. If they're not true, then flip it back to white. What if we said something like logical OR, which is another compound operator? Logical OR means that this stuff will happen if only one of these is true. And so you can see we're getting a lot more red because now S is, kind of parked on 9. So it's just a different, a different thing, a different result. These are definitely super important and something that I think you can do a lot with. There's an example on the slides. There's some pseudocode in the slides that I wrote. It's the example code that I usually use, but I just decided to do something a little different today. There is some example code here, right here, where it will basically turn a certain section of the window a certain color based on the I'll show this to you, based on the coordinates. So in this short code that I wrote just to illustrate kind of how these compound operators work, here we're basically asking, okay, if mouse x is less than width divided by 2, and mouse y is less than height divided by 2, then draw some stuff. And so let me just show you how this works. Wow, my computer is like, for a second there I thought my computer was broken, but it's not. It's doing exactly what it's supposed to do. I'm going to add a background to this just so you can see where the window actually is. And let's do like a dark gray background. So now you can kind of see what's happening. Like I was like, whoa, it's not working. Well, it's only working in one corner of the screen. And then when I try to mouse over the other 3 corners of the screen, it's not working. And that's exactly what we're telling it to do. We're basically saying, okay, if mouse x is less than width divided by 2, so width divided by 2 happens to be the central axis of the window. And so it's basically has to be over here. And so that, would be all of this. But then we're also asking that it be the top half of the screen, which then limits us further to this. Okay, so this is just like a short piece of pseudocode that you could potentially, apply in an assignment or something like that. I just wanted to make sure I showed it to you. Let's go ahead and keep moving a little bit. So one of the things that I'm really kind of excited to show you is how to use a for loop, which this is something that we're going to talk about at length on Monday, but I want you to just get a little bit of exposure to it right now. So it's really common when people are first learning how to code that they basically code exactly like this. In fact, I think I'm going to go ahead and post this, so hang on. Okay, so, excuse me, I'll stick this in the draw function because it's stuff that's drawing to the screen. So it's super common for people to code something that looks like this, which is basically just, like a row of ellipses, right? and you kind of itemize the details of every shape. Is that bad? Is that good? I wouldn't call it bad. It's a little bit labor intensive for my tastes. So if you just take the time to kind of understand for loops, you can get around doing this type of coding. And you can see that I constructed the ellipse in a way that it does have this sort of extra number that's getting added onto it, right? So it's basically, the ellipse is moving down by 10 every single time it goes through, an iteration. So what we could do is we could basically use a for loop, which for loop is a sort of fancy word for it. It's called iteration. And it's a way of taking repetitive lines of code and making them very compact and fully parameterized. So basically, you can take this little chunk of code right here, and it is fully equivalent to all of these statements. So you can understand why coders would prefer doing it this way, because it's much more efficient. It also allows you some probably other options that you wouldn't necessarily have if you're typing out each line of code, right? So let's talk about how we get there, because it takes a bit. Now, I also want to just recognize that here we have 10 lines of code, and we're going down to 3 lines of code. The kind of stuff that I usually use for loops for is 10 would be like my limit in terms of code that I'm willing to actually type out myself. Otherwise, I would probably use a for loop if it's more than that. Definitely, when you're using for loops, you can save yourself tens of thousands of lines of code. If you're using, like a large data set, or you're maybe drawing something that has a lot of coordinates. So the efficiency goes up based on the kind of complexity of your project. But let's take a look at this, and then, as I said, we're going to talk about this in quite a bit more detail. So to make a for loop, you basically would start by using the syntax for, and then there's a very specific sort of syntax for actually evaluating the for loop. So I'm going to just cut and paste this because I want to make sure I get it right. And I'll play around with some of these parameters and show you how it works. So basically, you have these 3 elements in the for loop, and then you have curly braces, and the curly brace goes all the way around whatever you think you want to draw, okay? So now here, we start with a variable. And so this variable happens to be called I. It is basically what some people call this an indexing variable. So it's a variable whose only purpose in life is to count and to navigate us through this for loop. Okay? It doesn't also, this variable, you can use this variable within the for loop, but it does not exist outside of the for loop. You can't come over here and say something like I equals blah, 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 because literally I does not exist outside of that for loop. Okay? So then the second part here is called the evaluation. And so basically what this is this is a limiter to keep your for loop from running forever. So this effectively puts a lid on your for loop. So in this case, I is less than or equal to 100. If I starts to go over 100, the for loop will cease to run. So it doesn't run without that. And then lastly, there's an increment or decrement statement. And so in this case, it looks like we're incrementing it by 10 every time it runs. And so if we were to run it now, guess what? We're still in this zone where we're doing exactly the same thing. So I'm going to delete these other 3 lines of code, or other 9 lines of code that we don't need. And we're still, at this point, not sort of fully using our for loop. So this for loop is definitely working. If we wanted to, let's say, print the value of I, you will see I iterate from 1 to 100. So let's go ahead and do that. And as promised, I is iterating from 1 to 100 by 10, right? Because we're incrementing it by 10. So how do we get I to kind of apply to what we're drawing? Well, the answer is really simple. We're going to take this 0 here. Remember, this 0 is what was controlling the sort of position shift. We're going to stick I in there. And at that point, we should basically allow I to the numerical value of I, which is iterating up by 10, to substitute in for those coordinates. Okay? So that is kind of like, in a nutshell, how to use a for loop. You can do really amazing, fun things with for loops, like add a little rotation in there, see what happens. You can change scale. Any parameter that you can think of, you can address with a for loop and make it sort of change gradually. So it's also especially cool for color. You can use a for loop to create color gradients and things like that. Probably next class, I have a feeling that just because it's so gloomy outside, I think I'm gonna do like some kind of rainbow thing on Monday, where we're gonna let's make some rainbows. Yeah, that'll hopefully be pretty fun. So don't hesitate to reach out if you're having issues or you have questions about all of this. It's a lot. And yeah, if I don't see you, have a fantastic weekend.